So, today we're going to break down a very important topic: dependency injection in Flutter. This topic might seem complex at first, but we're going to go through it step by step. We'll look at how it's used together with clean architecture, BLoC, and network requests. Let's go. Dependency injection is a design pattern that allows us not to create objects inside other objects, but to pass them from the outside. This makes the code more flexible, testable, and easy to maintain. Imagine you have a class that works with an API. Instead of creating the HTTP client directly inside this class, we pass it via the constructor. That's dependency injection. First, I create a folder called Features. This will store all the features of our application. As an example, we will simulate working with fetching users, so let's add a corresponding folder. Then, I'll create a separate core folder. This will hold shared classes for the entire application. Here, we'll create a folder for working with the API. We'll start by creating a file named api-client.dart. It's needed to get an instance of Dio so that we can make requests. But before that, we need to add the Dio dependency in the pubspec YAML file. While we're at it, we'll also add the getIt dependency. After installing the dependencies, we return to our file. Here, we declare a class. Now, we need to declare a method for getting the Dio instance. We initialize Dio using its default constructor. After that, we need to specify the URL to which the requests will go. For this, we use the options field and base URL. I'll pass a link to the JSON placeholder website. This site returns mock data in JSON format and is perfect for learning. Then we return our instance. Next, go to the users folder. We divide it into 3 parts: data, domain, and presentation. I have a more detailed explanation of each part in a video about clean architecture. Let's start with the domain and create a model inside it. We create a file called userModel.dart. This will be a simple class with fields like ID, name, and email. We'll also write methods for serialization and deserialization into from JSON. I have guides on this topic, so we won't focus too much on it now. Next, we create a repository. It's an abstract class that defines a contract for what we must return. Here, we declare one method to get a list of users. Then move to the data folder. We'll start with the data source. We'll call it user_remote_datasource.dart. This will be a class that performs network requests. For this, it needs Dio. And here, of course, we could create the Dio instance manually, for example, in the constructor or the method. But a more proper approach is to use dependency injection. This means we simply declare this field and initialize it in the constructor. Thus, we need to pass it at the time of calling the constructor for this class. Now, let's declare a method to get users. It will be a future, as network requests take time to complete. Don't confuse this with the method we declared in the abstract repository. That one is for the repository. Now, we're working on the data source. Everything is standard here too. I create a variable and call the get method, passing the URL. Then, we deserialize the objects. Next, we create a repository on the data level. This will be a file that implements our abstract repository from the domain folder. To work, it needs to call our data source. Again, we use dependency injection, initialize the field, and declare it in the constructor. This class implements our method. Here, we simply return the result from our data source method. After that, we create a BLoC in the presentation folder. Let's start with the state. I usually use one state for the block. First, I declare an enum for statuses, then the class itself. I declare fields like status, error message in case of an error, and the list of users. All these variables are declared in the constructor, and I make it private. Then, I create a factory constructor for initializing our state. Here, I just pass the status, as it's the only non-nullable field. Then, I declare a copy with method, which will be needed for changing states. I also have a lesson about this on my channel, so we won't dwell on it now. Next, we create events. We'll have an abstract class for the event, and one class that extends it to fetch the user list. Now, let's create the actual block. But before that, let's also add the package for BLoC to our project. Note that we need access to the repository here. There are several ways we can do this. First, we can declare a field with the implementation of our repository. The second option is to declare a field with our abstract repository and pass the implementation to it. But then, we'll have to pass all other dependencies too. And the most proper option is to simply declare our abstract repository and place it in the constructor. This way, we know that our block will implement the contract, but we don't care about the specific implementation. That's not our concern on this layer. From here, everything is standard. We just configure our block with our events. Once we've done that, it's time to work with Gedit. Let's create a file called Dependency Injection.dart in the core folder. This file will be responsible for setting up all our dependencies. Here, we create a global variable for our service locator. Now, we create a function to initialize all dependencies. We start from the top layer. That's the API client. To register it, we use our variable and the register singleton method. In it, we pass the constructor call for API client. Note that since API client is at the very top of our dependency chain, it doesn't take any dependencies in its constructor. Now, let's break down the register singleton method in more detail. This method creates an instance immediately and always returns the same object. Besides it, we also have the register lazy singleton method. It creates an instance only when the dependency is first accessed, not right away. And we also have the register factory method, which creates a new instance each time it's accessed. But for our API client, we need to use register singleton because we want to have a single instance for the whole app, and it should be created right at the start. Now, let's register our user remote data source. Here, we'll use the register lazy singleton method. Why this one? Because the data source isn't needed right at the app's launch, it's only needed when we start making network requests. As a parameter, we pass an anonymous function that returns a new instance of user remote data source. But note, the constructor needs Dio. How do we get it? Easy. We ask getIt for a Dio instance. But wait, we haven't registered Dio. Let's fix that. Let's register Dio right after API client. Here, we also use register singleton and pass the result of the getDio method from our registered API client. To get API client, we again use getIt. Perfect. Now back to our data source. Now getIt knows what Dio is and can provide it. Next step, we register our user repository. Again, we use register lazy singleton because we don't need the repository immediately at launch. Inside the anonymous function, we create user repository MPL, our concrete implementation of the abstract repository. In the constructor, we pass our data source, which we get through getIt. Note that now, when we try to get our repository, for example for a block, it will return the concrete implementation. Finally, we register our user block. Here the situation is interesting. We use register factory. Why? Because BLoC is a stateful object, and in different parts of the app we may need different instances with different states. Factory guarantees that every time we get a new, clean instance. In the user_BLoC constructor, we pass our user repository, which we get through getIt. Awesome! Now all our dependencies are registered. Now we need to call this initialization function in our main.dart file. Open main.dart and add the function call. But before that, we add widget's Flutter binding ensure initialized. This line ensures that Flutter is fully initialized before we start registering our dependencies. Then we launch our app with the standard run app. Perfect. Now all our dependencies will be registered when the app launches. Now let's write the page to display all of this. We create a stateless widget called users page. In the build method, we use BLoC provider. In the create parameter, we pass a function that returns our BLoC. Notice how we get the instance of our BLoC. Through getIt, specifying the type of user BLoC. We simply ask our service locator for the user BLoC instance. getIt knows how to create it because we registered it as a factory. And right after creating the BLoC, we add the getUsers event to start loading users. In the child, we use a standard scaffold with appbar. In the body, we use BLoC Builder to track changes in the BLoC's state. In the builder function, we get the context and the current state. Then comes the standard logic of handling states. If the status is loading, we show a loading indicator. If error, show an error message. If success, show a list of users in a list view. Let's run our app and see the result. As we can see, we have a Dio error. The issue is that we forgot to add a trailing slash in the URL. Now, let's try to restart our app. As we can see, everything works. Now, our dependency chain works completely automatically. When we create user BLoC, getIt automatically creates user repository for it, which in turn gets the user remote data source, which gets DIO from API client. The biggest advantage of this approach is that we can easily replace any dependency for testing. Just register a mock object instead of the real one. Thanks for watching. Don't forget to like, subscribe, and hit the bell so you don't miss the next video.